Aloha and welcome to this short screencast where I'm going to introduce software review. And the goal for this screencast is, to understand why software review or technical reviews are important. I want to talk with you a little bit about software inspection, which is a highly formal process and the one that's used for really mission critical kinds of code. So if you're writing software for the space shuttle or for an airplane, medical instrumentation, and so forth, then you want to ensure that the code is of the highest possible quality. Software inspection is a formal process that helps you get there. Since we're not writing aircraft code or medical software, we're going to use a somewhat less formal process for this class, but one which I still think will really take your developer skills to the next level. So I'm excited about that. So I want to first talk about how review fits into the other kinds of quality assurance that you've used in this class. So you have used automated coding standard checkers. So we were using ESLint, and that's super useful. Everybody should be using a coding standard tool like ESLint, or in Java world, it's CheckStyle is the standard, because those tools automatically detect and sometimes even help you fix low-level standards, indentation, formatting. Maybe there are deprecated functions you shouldn't be using. Those kind of tools can detect those things for you, and you can also configure the set of rules. So you can have for a development team, you can decide what are the standards we want to obey at this low level. So that's awesome. Definitely want to do that. Another kind of quality assurance is testing, and we have unit tests, integration tests, acceptance tests. Some of the tools, lots of tools out there for that, but I'm going to say Mocha, Chai, Test Cafe, etc. And testing is super good at ensuring that your code performs correctly. You can never completely test your code in the sense of guaranteeing that it's 100% correct, but the more tests you have, the more assurance that you have that things are going to work. And you want to kind of reach a nice trade-off. In my opinion, the trade-off is you want, when you're writing new code, you want that sense that when you run the tests, you didn't dramatically break something someplace else in the system. So it's helpful for increasing the velocity of development, because you can, as a system gets large, it's hard to kind of keep in your head all of the different ways some new piece of code might impact on other pieces of code. And so tests can really give you some assurance. However, there's stuff left over. The first thing is, how do you detect that your software just simply isn't implementing something that it should implement? Okay, well, coding standard checkers and tests are never gonna detect errors of omission, right? You can only test something that's actually there. You can't test to see that something's not there. And so we need something else for that. We also, need something that can help us determine, are we implementing the code in the best possible way? So a test, an acceptance test or a unit test, that can determine that your code, achieves the requirements, but it doesn't test to make sure you've done it in the most optimal way, the most readable way, the most maintainable way, the most, readable way. Okay, and then finally, tests and coding standard checkers have really limited impact on your ability as a team to write code in a consistent way and understand what's the better way to write software. So with software reviews, these are the things we want to focus on, not the stuff that's easy to do via testing, not the stuff that's easy to do with an automated coding standard checker like ESLint. We want to focus on these other levels, okay? So there's essentially three kinds of software review. There are software reviews, and we call them walkthroughs, technical reviews, and inspections. Walkthroughs are the most walkthroughs are essentially, you go over to somebody else's cubicle or desk and you say, hey, I wrote some code, can you take a look at it? And the person looks at it and kind of says, yeah, it looks good or doesn't look good, or have you thought about X, Y, or Z? And the good news about that is there's no overhead. You don't have to follow a process. You're just getting some advice from somebody else about your code. And oftentimes that's really useful. That's all you need, and you should not feel bad about doing it. But it's not necessarily the most guaranteed efficient way to get high quality feedback. So there are the next level up from walkthroughs in terms of formality are called technical reviews, and there, you have some level of process involved. You have a few different stages, and the goal there is with a little bit of process, hopefully you can improve the effectiveness of the review, but it will take a little more time, a little more overhead than a walkthrough. And then the last level is called a software inspection, and this is a very formal process, and a lot of research has been done on it. And the goal there is that you want to make sure you find as many defects as you can, okay? And it's not about, avoiding cost in a sense, because if the space shuttle blows up or the International Space Station runs out of air or whatever, then that's catastrophic. So the process is quite formal in order to make sure that the review or the inspection is going to find as many things as it can. So there's some things that are cool about reviews, software reviews. The first thing is that it turns out that reviews improves schedule predictability, and the idea there is that if you don't have reviews, then particularly as you get to the coding phase and the testing phase, things could take wildly different amounts of time, and it's hard to know kind of how long the coding phase will last or the testing phase will last. It turns out that when you insert reviews into the process, so after the requirements phase, you do a review and you find errors in your requirements and you fix them during the requirements phase. And then you do a design of your system and you do a review. That, because the requirements have been kind of assessed and problems removed, the design phase is generally shorter because you're not discovering errors in your requirements during design. And then if you do a review at the end of the design phase and detect and remove errors from your design, then the coding phase is shorter, because during the coding phase, you're no longer discovering those design problems and having to remove them via changing your code. And similarly, if you do a review during the coding phase, then the testing phase takes less time because you're just detecting less errors through your tests and avoiding rework. So you can see in this first little diagram, the design, code, and test phases are a little bit shorter as a result of having inserted reviews, and in general, the cost of inserting reviews is less than the cost of the rework, so the overall time to development should be less when you have a good review process in place. And this is the essential characteristic of reviews, which is that they reduce rework. So rework is where during the design phase you discover requirements problems that you need to fix. During the coding phase you discover design problems that you need to fix. During the test phase you discover coding problems you need to fix. The less of that rework you need to do, the better off you are, and reviews are good at that. And as I said before, reviews are interesting because they can find certain kinds of problems that you can't find through testing. And finally, reviews help people learn. So, it's one thing to be able to get your code to work. It's another thing to get your code to be, easy to understand, easy to maintain, easy to test, using the right kind of design pattern and so forth. And reviews are the way that you can get to that in your group. So let's look at the most formal type of software review. It's called software inspection. It was first defined in the mid 70s, and is still used in life critical kinds of software where it's really important that you find as many defects as you can. And it has these 6 different phases: planning, orientation, preparation, meeting, rework, and verify. So let's really quickly look at each of the steps. During the planning phase, you figure out what it is that you want to review. You assemble the information, the work product checklists, etc., that are required. You decide who should be on the team. You determine the dates. Then there's an orientation session where the team gets together. The author provides an overview of the software to be reviewed during that phase, and whatever preparation techniques people want to use are going to be established at that point, and the reviewers say, yeah, I'm in. Then the preparation phases start. Each developer works kind of independently, trying to find the maximum number of non-minor issues, and these issues are typically classified as critical, severe, moderate, or minor. There can be other classifications, but the point is that you don't care about minor defects in software review. In fact, in any review, you really don't care about the minor defects. You really want to find the moderate, severe, and critical ones. Then during the review meeting, everybody gets together and you create a consolidated list of all the non-minor issues. You talk about the issues and talk about the work product. Then during the rework phase, one or more people are assigned to deal with every single issue that's discovered, and you resolve them in whatever way is appropriate. And then finally, you have a verification phase where the author or somebody else goes back through and ensures that all of the issues identified in the meeting have actually been addressed during the rework phase. Okay, so as you might expect, this is a time-consuming process. There are often trainings involved with getting people to understand how to, use software inspect in their organization, but the outcome is that if you follow this process and get good at it, you're going to find a lot of errors in your code, but there will be, a fair amount of overhead involved with that. Although, as we saw earlier, that overhead is generally not as much as the overhead incurred by not doing reviews at all. Okay. So in this class, we're not going to do that highly formalized software inspection. We're going to do a more lightweight process that will be a technical review. So there still will be a little bit of structure to it, but it will be less than inspection and also kind of integrated into our issue-driven project management process that we're using for development. So the goals for our technical reviews is that, we want to learn how to obtain useful feedback from your fellow developers about the software system. If you go into a review and people are raising things that are kind of silly, or they don't say anything at all, then that's not good. We want to learn how to be able to give and receive useful feedback. Secondly, we want to be able to read code written by other people, and I think most of you will enjoy that. That's a great skill to have, and will vastly kind of level up your coding ability. I'm hoping that what will come out of this is a sense for how to do reviews that you come out of with a sense of, wow, that was really helpful to me. I learned a lot from doing it, and not, whoa, that was just a waste of time. Nothing interesting happened. Another goal for the reviews is to build checklists. So we, like inspection, we're going to have checklists, and one of the principal goals of the technical reviews practiced in our class is to be able to incrementally build checklists that are better and better and better over time at defining the kinds of things that constitute well-written code along various dimensions. So one of the outcomes is to not just to find errors in the code, but to, in a sense, find errors in your checklists. Find things that in the checklist that can be improved. And then finally, get better as a developer. All right. So, I think most of you are learning that it's one thing to be able to get the code to work. It's another thing to have the code be something you might want someone else to look at, right? And so the only way to go from kind of, code that just works, but you're ashamed of in some sense, to code that you're proud to show other people is by going through the review process, having other people look at it and help you learn, what was a better way to write the code. And reviews should be friendly, kinds of activities. We're all in it together. We're all trying to learn. We're all trying to get better. And it can be a really fun way to understand more about software development. So what we're going to do in our process is for each review session, it's going to involve a fairly small amount of code, a couple, 3 files, 200-300 lines of code. The idea is that we don't want you to have to spend more than about an hour preparing for the review. And in order to make sure that's true, it should be a small amount of code. And when you go in, there's always going to be checklists that will be specified that help you understand what it is you should be looking for. Okay? And then once you get done with the review, yes, hopefully there'll be some problems with the code that have been identified to make it better. You'll create some new issues that you'll put in the to-do column and schedule for fixing the things that you think are important in the code. You'll update your checklists at least in some reviews, you'll update your checklist because you'll have discovered, hey, here's something interesting we should be making sure happens all the time that we didn't realize before. And then finally, as a result of having kind of talked about the code and looked at other people's code, the team will naturally start to code in a more consistent and high quality fashion in the future. So how do we do it? Well, there's about 4 steps to it. The initiation phase is where somebody in the team is going to decide there's some code I'd like to see reviewed. Maybe it's my own code or somebody else's code. And so I'll create an issue in issue-driven project management, and it's going to specify the files to be reviewed, the checklist that should be used for the review, when the review meeting is going to be held, and then any other kind of high-level goals that are required for the meeting. You'll create a branch in your repo. Instead of being issue dash 023, it'll be called review dash 023 to specify that this is a snapshot of the code that people can look at. And the nice thing about creating a branch is that other people can be updating master and doing other stuff that could change the code. But you've got a static snapshot that won't change, that makes doing the review a little easier. And then once you've created this issue, you move it to the in progress column so that everybody knows that this is something that's assigned to them and they should be working on. So here's an example of an issue. You can see it specifies the review branch where people can find the code. It specifies the files. These are all links actually into the the GitHub repo. It specifies the checklist. Again, these are links to the actual checklists. And then specific request for this review is just stuff by the author that they want people to look at. What's the due date for this, and any other documentation. So that's an example of the initiation phase. So after that's been published, the preparation phase is several days where the developers need to put in an hour reading through the code, looking through issues, and then creating some private text document. So you don't share things with other developers during this phase. Everybody should be working on their own and not sharing it. That way, it's good in terms of helping folks to not be biased by what other people are producing. So you specify the file and the line number, whatever the checklist item that was violated, if there was a checklist item, or any other issues that you find, and hopefully if the review was packaged, the files were small enough that it should only be about an hour's of work. So here's an example of the preparation phase, and this happens during the review meeting. You actually put your private text into an issue, and I'll get to that in a second, but I'm just giving you an example of the kinds of issues that could be discovered during that preparation phase. Then during the meeting, the first thing that happens is each developer creates a new comment in the review issue. So this is the example of mine. And then you can finally see what other people have seen. And then you go through the code, and that's fairly unstructured, whatever kind of makes most sense. But the outcome is a new comment at the end of the meeting as part of that review issue that's going to specify what new issues should be created, what new checklist items should be created, and any other information. So here's an example of a new comment created at the end of that review meeting that specifies, okay, we want to create an issue where people that are using Lodash should actually use the built-in functions when possible. Here are 3 new checklist items that we should be adding to our checklists. And there's a couple of other issues that we identify that we should think more about. Okay, and then following the meeting is a resolution stage. Resolution stage is basically create new issues that as identified during the meeting and put them in the to-do column so that eventually the problems that you saw with the code are going to be fixed, and update your checklist items to improve things. All right, so there's a little overview of software inspection and the process we'll be doing in our class for review. Hope you enjoyed it.